So I'm sharing the screen. All right, so we are sharing the screen, right? So this is now your second homework assignment, okay, which will just be one problem, nothing more. Okay, and it's just to playing a little bit with cipher algorithms, kind of motivating that idea. And so we'll go ahead. So let's go to the table of contents on Brightspace. Okay, so we are done with this module at this point, secret key. That module's done. Your link should be there for your submission. And it's available, I think, until September 1st for you to submit your homework. Please, after that, make sure you submit because it'll close and I don't accept homework via email. Okay, so that's my one very hard rule. All right, so now we are ready to move on to the second module, Python Substitution Cipher. So this is it, right? So I'm gonna click on the Word doc. Wait for it to open. Did it open? Okay. All right. So homework substitution cipher. Complete the following problem as done in class. Submit a report showing evidence that you completed the Python substitution cipher as discussed in class. You need to run it without errors and show evidence of encrypting and decrypting something. And submit a report showing your work and results. Okay, so I will finish the code. And then you need to be able to encrypt something with it. It'll be like a string of text, put your name on it, and you'll need to encrypt and decrypt. Got it? So we're not going to use anything that's advanced or XOR or anything like that. This is the only time that we're going to use like an old cipher called a substitution cipher. As I said, I used this example to kind of get us started with Python and practicing a little bit. And also just to show that even something very insecure like the substitution cipher can be hard to implement. Okay, it's got its trick, right? So you'll see it's got this weird logic that will make you think a little bit. All right, but it should be fun. All right, so we're gonna code it in on the VM in Python. So I'm gonna go over here and I'm going to. So this is where I am. There are no files. So now I'm going to, we're not going to read from a file later on as we move through the semester. I will show you some of the code necessary for you to read, from a text file. Usually we're going to want to read and write to text files because there's a lot of things that are going to happen here. Like we need to generate keys, we need to generate ciphers. We need to read in the plain text and so on. So it involves a lot of being good at that. But for this example, I'm just going to start with the basics. We're going to hard code the string, okay? So let's call this one example 1, something like that. Or actually, let's say substitution cipher .py, okay? So I'm just going to do an example to make sure that Python is working. So I'm going to do print hello. That's in the Python language, of course. So I'm going to do Control X, Y, enter. And please, if I'm going too fast or if you miss something, although I'm recording, stop me, okay? And I'm happy to repeat it. But sometimes I just go, so. All right, so I've created the file there, right? Now I want to show you, so this should be Python here. Now, when you guys type Python like that, do you get a prompt like I just did? Or do you get an error? You got an error? You too? Yeah, so my tool is a little bit different from yours. I think you have to type Python 3. And then you should get, right? Yeah, you guys have to, I have something installed on here called Anaconda, which allows me to just type Python. You don't need to install it. So every time I type Python, you just have to type Python 3. Does that make sense? That's probably the only difference, I think. Keep in mind, we are using Python 3, so the code needs to be for that version. Questions? All right, if you type Python 3 like this, you can already do code, like you can do m equal 1, and then m, right? And then if you do m equal m plus 1, it's now 2. So as you can see, I can do operations. This is called a Python interpreter. So you can code like this if you'd like. I won't be coding like that. Instead, I'm just going to run the script. So my script was called Substitution Cipher. So I tab it, and then this is basically the format. Does that make sense? And we can run it just if you type Python 3 and run the substitution cipher.py file, you should get hello. Show of hands if you got that, please. Just to make sure that everyone is following along. Huh?
How did you argue?
From the X, yeah, so Python 3, and then you have to type exit and then open and close parentheses. You could kill it, yeah. But if you do this, it exits. Got it? Yeah, okay. Any other questions, guys? Yes, please. Yeah, of course. Which one? The interpreter or running the script? Running the script, yeah. So did you see how I created the script? Nano, right? So you just do nano, the editor there, give it a name. You know, I went to the code. I can add another print just to, and you know, hello 2, right? And then Control X, Y, enter. That just makes it easier. I like just using the terminal because, you know, we have full control there. And then to run it, you just have to type Python or Python 3 probably in your case. And then substitution, that script. If you forget the name, just type ls-l and you can see everything. All right. So Python substitution, I tab it so I don't have to type the whole thing. And then you press enter and now it gives you 2 hello. Got it? Got it, guys? So this will be basically how we'll do things when we're not using OpenSSL or a tool like that. And we'll probably be using Python just to understand some of the algorithms, basically. Okay. Questions? All right, so now let's look at the problem that we want to implement. So I'll just read this for you. It's short, basically. So the problem is as follows, okay? So consider some text, just a sentence like, you know, whatever you want to say. My name is, you know, something, Mary Sue, and I'm studying fundamentals of cryptography in fall 2024. Just some sentence, whatever you want it to be. So consider a sentence. So you need to show the process of encrypting and decrypting the text by assigning numbers to the letters. Okay, that's it. So you have to, it's a substitution cipher. So what that means, it's almost like a code book. You have the letters and the numbers, and you're just going to be replacing them. But there's a bit of a trick. There's going to be like the logic for this cipher is let the alphabets be assigned values from 26 to 1. So there's 26 letters in the alphabet. We're going to keep it, we're going to make some limitations, like there's only going to be letters, right? So if you want to have numbers, this will work too, but you just have to extend it a little bit, your logic. We're going to be using the ASCII table also, okay? So I gave you the ASCII table, if you remember, for week 1. This actually, you know, it'll take some time for you to think about it, but you'll see eventually that this algorithm is meant to be used with the ASCII table. It makes sense to use it that way. So let the alphabets be assigned values from 26 to 1, i.e., in the reverse order of their actual numbering. For example, A would be represented as 26, B as 25, and so on. Does that make sense? That's it. That's the whole algorithm, okay? And use the ASCII table if you can. Got it? And this can be extended, by the way, to numbers, although initially I'm just going to do this with letters. Any questions? All right, so let's start then. Let's go ahead and start. So I'm going to open Nano again, and I'm going to start coding. I'm going to comment these, well, remove them actually. I don't need them anymore. And I'll just add in a comment here, basically the logic. So A should be 26. B should be 25. And so on. So, you know, dot, dot, dot. So the letter Z, for instance, should be probably 0 or 1. Probably 1. There's 26 letters, right? So it should be 1. Does this make sense? Guys? So when you encrypt something, a sentence, it's going to be just a sequence of numbers. Probably like that, 0, 1. Okay? A 2-digit number, basically. All right, so that's the whole substitution cipher. Let's get started. And if you have any questions, just let me know. Now we have to do both the encryption and the decryption. Okay, so that can be 2 functions or 1 function, etc. Okay. So let's see. I'm going to create a function. So encrypt and decrypt, okay? And this is actually, so what I like about this example is this one is very simple, but some of the functions and the format of this will be very similar even as we start moving into RSA or XOR. You know, the actual operation might change, but the logic of it will be similar, okay? Some aspects of it. So in this case, I'm going to create this function encrypt, okay? I'm just going to say 1, 2, 3, 4. Remember, Python has indentation, return. Okay, and then I'm going to create another function, decrypt. Okay, colon, 1, 2, 3, 4. Return. Got it? Just like that. Okay, so then, all right, so we have this function here. Then we can add maybe some lines just to kind of separate this out. You're going to need to have a string. String here is going to be called plain text. And it's going to be something like, you know, today is. Now, keep in mind, there are no uppercase initially, but it would also work for uppercase. So that's the nice thing about this. I'm keeping it simple right now, just so that we don't have so many characters to translate, but actually the logic could work. The same logic could be extended to numbers in uppercase, but I'll keep it to lowercase for now. So today is Thursday. And I am in Hammond or something like that. Okay, right? It can be any sentence. Just keep it Simple. All right, so that's my plain text. You're gonna have a cipher, which is just gonna be a sequence of numbers, right? So, but initially we have to start with the plain text. So once you have done that, you can start the process. So you can just say cipher equal, or you're gonna assign to it. You're gonna encrypt. And you're gonna pass to it plain text. Does that make sense? And then once you have done that, you can print cipher. Okay, so this is the basic structure of what we are always going to do, pretty much. The only thing that will be different as we start moving forward is that we will need to also create things like keys and things like that. This example, if you notice, does not use keys because we just have this mapping logic, okay? For as a warm-up to what we're doing. All right, so and then once we've established the cipher, then we are going to want to decrypt it. So then you would say new plain, and that would be equal to decrypt, and then you're going to plug in here the cipher, and then we would print new plain. And if you're successful, you should get the original message. Today is Thursday, and I am in Hammond. Does that make sense, guys? So this is your screenshot that you will show in your lab needs to show that you encrypted it and then decrypted it successfully. Okay. All right. So now let's get started. All right. So we have about 30 minutes. Okay. So what I would recommend is I'll try to complete as much as I can of this. And I recommend that you guys try to finish it on your own, right? By next week. And then if we'll discuss it next Tuesday. Make sense? I do recommend that you use it as practice. Get yourself practicing about these algorithms. Should be a fun one. All right, ready? Any questions? All right, so let's go ahead with the first part, right? So I'm going to do encrypt here. And we are going to give it our variable text here. That's the input to the algorithm. Remember the indentation, 1, 2, 3, 4. Okay. So we need a variable to store the new cipher. So I'm just going to call it SS. Give it any name that you want. I'm going to initialize it to nothing there. I'm going to use double quote. All right. And then 1, 2, 3, 4. Okay. Actually, I'm going to do one more thing. I'm going to comment out these two. So as you know, when you run a script, you don't want to spend 3 hours writing a lot of code and then run it and expect it to work, right? That's a bad idea. So instead, what I'm going to do is I'm going to clean it up in such a way that I can start running it right now, and just to make sure that everything is looking good. So in this case, if SS is going to be our output, then that's what we're going to return, right? So SS. All right, so I think this script will run. So let's do Control X, Y, enter. Now I'm going to do Python, and it should just give us no errors. And it tried to print out SS, which is currently empty, right? But it's working. Any questions? All right, so we can proceed now to continue to encrypt here. All right, so the next step is assuming that you made a mistake, and you wrote I like uppercase or something like that. We want to deal with that issue. And so what I'm going to do is I'm going to make it all lowercase. So I'm going to do text, and I'm going to assign to it text dot lower. Just like that. Okay. Then so what do I need to do now? I'm going to encrypt every letter into a number, right? So what is the first letter? T. So what number is that going to be? Like 9, something like that, right? So that's what I need to do. So there's a couple of ways that I can do this. One way is for you to create a whole bunch of if statements, like if T, then 9. You could do that. But that's probably not the best solution. There's a more interesting solution, I would say, and that is to take advantage of the ASCII table. So if you go to the table of contents and you go to the first module, I think I placed this ASCII table in the wrong module. It should have been in this one, and I just put it in this one here. So if you click at that ASCII table, so this is an ASCII table I've had for a long time. And if you take a look at it, right? So what are the letters that we care about? We care about lowercase a through Z. So let's take a look at them. So that's A all the way to Z, right? And then we have a hex value and we have a decimal value. And if you look, A corresponds to 97, right? And Z corresponds to 122. You see those numbers? Okay, so maybe, or a more interesting thing might be to use the ASCII table. So we can bring in the ASCII table into Python, for instance, right? And so we can say, okay, using the ASCII table, I give you D, give me the number for D, the decimal. So that should be 100. Do you see that, guys? So we can do that. And the advantage of doing this is that if you implement the code in this way, then when you do uppercase and numbers, it will also work, okay? But the problem is that the mapping is not what I want you to use, right? I've made it more complicated because I could have made it simple by just saying, give me a 100, 101. But I want A to be 26. And I want B to be 25 and C to be 20 and so on. Okay, so that's what we need to figure out in this problem is how do we leverage the ASCII table, but once we've got the numbers from the ASCII table, convert them to the numbers that we want. And you'll see that there is a pattern going on. And that's the whole key with cryptography, right, is breaking these patterns. So that's what I'm trying to get you guys to think about is, how can you solve that problem? Does that make sense, guys? So let's start doing that first, right? So we're going to leverage the ASCII table, which you have here. So let's go back. So first of all, I need to iterate through all the letters, right? I'm going to do every letter one by one, okay? So in the sentence, today is Thursday and I am in Hammond. So I'm going to do a for loop for I in range. For I in range, colon, and then here I'm going to say length, which is the length of text. One nice thing also to do is to print a lot. So I recommend that you do this to debug. Do length of text. And then we can comment this one out for now. We just want to know the length of the sentence, right? So I'm going to do Control X, Y, run it. 87. So we have 87 letters is including spaces in there, right? And the space actually, how are you going to handle that space? Is there an equivalent in the ASCII table for space? What do you think? There is, right? So that's good because then you can also use, that's why it makes sense to use the ASCII table for this kind of problem. It gives you a lot of help. All right, so now let's go ahead and we don't need to, I'm just going to comment this one out because I just wanted to know how many letters I have. But now I can add the for loop. So now what this tells me is I'm going to grab from that sentence of 87 characters, I'm going to grab each one by index, starting at 0, and I'm going to try to encrypt them. So 1, 2, 3, 4. Okay, so the first thing I want to do is grab the letters. So I'm just going to say A equal text I. Do you guys see that? So I'm grabbing that first letter and I'm going to print it. Again, just for debugging purposes. So I'm going to say print A, and then I can add an input. And the input is like in other programming languages, like where you put a stop or something, and that way you just have to hit the keyboard so that you move to the next iteration. So let's try that. So what was that letter? I don't know why. That's the T, right? Yeah, just this big border. But you can see it's the T, then the O, right? The today. You guys see it? Guys? Do you all see it? All right, so I'm printing them basically, right? So I'm grabbing all the letters like that. Any questions? Yes, sir.
Can you go back to the coding?
Yeah, of course. Mhm.
Let's see, because I'm getting an error right now when it comes to the input.
Where? It might be an indentation error. So half the time your errors, what does the error say?
It just says something about use it. Oh, it's probably the spaces.
Yeah, don't mix tabs and spaces in Python. Use one or the other.
Okay.
Yeah, so if you use tabs, tabs. If you use spaces, spaces. But if you mix them up, it's gonna error out. Yeah. Any other questions, guys? Everyone with me? Everyone with me? Yeah. Okay.
Scroll down. It's a little bit.
Scroll down.
Yeah.
To where?
It's the near the bottom.
Mhm. That's it. Yes, sir.
I'll have to look.
I mean, you've been typing code. Right?
Yeah.
Are you sure you're typing in the right place?
Yeah.
Okay. Scroll down.
Yes. Spaces.
Yeah, I'll address that. It's Control X. LF dash L.
Yeah, we'll just do.
Two icons. You see that?
Yeah.
So the one that you've been modifying is the one that has the upper S. So do this. So you're running the lowercase one and you're modifying the uppercase. You see that? Just get rid of one of those. Guys, any other questions? Questions? Everyone with me? Making sense? Making sense for everyone? All right, so we've done that part. Guys, now the next thing we want to do is we can see that we had the letters, right? And I printed them. So now let's run these letters through the ASCII table, all right? Basically, so I'm going to create a new variable called N1, and I'm going to run it through a function in Python called ORD. And I'm going to give it the letter A, okay, guys? And then I'm going to repeat the same thing as I did before. So I'm going to do print, and first I'm going to print, since I'm having an issue seeing things, I'm going to do this, A, and then I'm going to print N1, okay? Oh, somebody asked me about the spaces. Okay, so I have this bad habit of adding these spaces here for readability and for when you have a lot of parentheses, it just helps me to make sure you don't actually have to have these spaces. If you prefer your code like that, that's fine. I just, as a habit, do that. Does that make sense? So you don't need to do it. Okay, you just have to worry about indentation, right? Okay. All right, so what I want to do here, and I'm going to add the input here. So what I want to see is I'm using this function to convert naturally from alphabet to number, okay? So we want to see what happens. So I'm going to go ahead and Control X, Y, enter. Going to hit clear. /L. Okay, now I'm going to run the script. All right, there we go. T is 116. Is that accurate? What is that? Let's go to the ASCII table. T is 116. You see that? Today is what we said. So O should be 111, correct? Everyone with me? So this is exactly what I'm showing you, is that we're going to leverage the ASCII table to help us out, because that way we can add numbers, uppercase, spaces, special characters, etc. And we take advantage of that to do our a better cipher. All right, so we should expect O to be 111, and then D to be 100. So let's see what happens. 111, 100. There we go. All right, so we are making some progress. But now the question is, we want to convert the letters to numbers. So we are doing that. But the cipher that I'm going to kill this. Okay, we're going to go back to the script. The cipher that I want you to do says that A needs to be 26, B needs to be 25, Z needs to be 01. Do you see that? So we are getting numbers, just not numbers in this scale. So now that's what you have to do. The next step would be to convert. So I'm going to comment these out. You have to take this N1 and convert it into the appropriate number. So T becomes 111, I think it was, or 117. And then that needs to become the actual number. So how do we do that? So there's several ways, right? You could create a huge set of if statements, etc. But we can actually just do a little function, right, that changes the number. Okay, so we just have to think a little bit about it. Right, so, and again, this is what gets at patterns and ciphers. So this obviously has a pattern, which means it's an insecure cipher, not very secure, even though it's complicated, right? So the function, I'll just give you the function. So the function should be something like, what do we need to do? We're going down, right? From 26, 25, 24. So code equal 26 minus something, right? Do you see where I'm going with this? Okay, so we want to figure out that math that will convert the numbers that we're getting to the numbers that we want somehow. Okay, so the numbers, so the key hint is if we go back to the ASCII table, A, B, C, D, E, right? 97, 98, 99, 100. What's happening to these numbers? They're going up. As we move from A all the way through C, the numbers are going up. But the cipher that I want you to do, what happens? The numbers actually go down, right? 26, 25, 24, and so on, right? They're going down. So that's why it makes sense to start at 26 whenever this number, we need to do some math so that the numbers go down, for instance, because in the ASCII table, they are going up, but we want them to go down. Do you see what I'm saying, guys? Does that make sense? Okay, so that's 26 minus. So obviously, N1 goes in here, correct? Goes in here. We have to do an operation with N1 within that parentheses that will give us the value to subtract from 26. What do you guys think could be the value? Yes, exactly. This is exactly what I want you to do, right? This is the cryptanalytics that you would, as you're breaking this cipher, you're like, okay, I already figured out one is going up, one is going down, right? So then you can start to break exactly right. So let's think about that. So how do we do that? I guess we can hard code A in here, right? So instead of doing, let's go with that actually. I think that might be. Do you see what I'm saying? Instead of grabbing the actual letter, which is a little bit more confusing, we can just give it A equal, remember it has to be double quotes, A. So this should give us an N1 of, what is A on the ASCII table? 97. Does that make sense? That should be a 97? Everyone with me, guys? All right, so let's try that. I'm going to go ahead and A goes into ORD, then N1. I'm going to comment this one out because it's not complete, and I'm going to re-enable these two. So A should be A, and N1 should be, I think, 100. And then we just want to see what code will be, right? So let's run it first like that. Let's see if I'm correct. Here, A is 97. Do you see that? There we go. Excuse me. So now let's kill this. Go over here. I'm going to add a new print statement for code. Code. Okay, so I'm going to print that one. So now we just have to do this math. Okay, so code is 26 minus N1, where N1 is 100, right? So let's see what happens. Minus 71. But we want A to be 26, right? Is that what we want? Guys? Okay, so come on, solve this, right? We need to crack this cipher. We're almost there. We know that we want A to be 26. Currently, A was minus 71, I think. Yep, okay. So what do we do here? N1 is what? N1? N1 was the ASCII, 97. Yes, 97, right? Okay. So what happens if we know it's 97? So what if we do minus 97? Oops, sorry, 97. It'll be 97 minus 97, that's 0. Does it give us 26? Let's try it. There we go. 26. Do you guys see that? Okay. So then how do we test this to see if it works? It may not work. I don't know. You need to test it, right? So what's the next letter should be? B should be 25, right? That's so we can test that too. B. And if this is correct, it's going to give us 25. Maybe. $25. There you go. That's it. Does it make sense? So at this point, you've implemented your cipher, right? So I think. Okay. Any questions? So that, yes, sir, please.
I was gonna ask, show me.
Yeah, of course, yeah. And I would recommend probably to also test it with Z, which should be, I guess, 1, right? So we want to maybe add that last one in there. Z is 1, should be 1. I'll just run this real quick. Yeah, it is 1. All right. Okay, so that was possibly the hardest part. And now you're leveraging the ASCII table, and you can generate the numbers as, based on this substitution cipher problem. Okay, so I think, we still have 5 minutes, so I'll keep going, but I've basically addressed the hardest part of this, which was doing that, right? Just keep in mind when you decrypt, you may need to do the same thing, but kind of in reverse, if that makes sense, okay? And remember, you'll know if it worked because you'll get the same sentence back, okay? So just throwing that out there because we got 4 minutes to go, but I've covered most of this, and just, try to solve this by next week. All right, so what's another thing that we need to address? So once we have the codes, we're going to have an issue. And the issue is that some numbers are going to have 2 digits and some numbers are only going to have 1 digit, right? So like the letter C is just a 1, whereas A was 26. That will create a problem later on in your encoding and decoding. So what makes sense is for the ones that are only 1 digit to put a 0 in front of it. And then that way, the conversion of letters is always to a 2-digit number. Make sense? That part you can do by treating the number as a string. Okay, that's kind of the idea. So what I'm going to do is, I'm going to say if code. Yeah, sorry, make sure the indentation is correct. If code less than, remember currently the number is an integer. So if it's less than 10, that's where you have a 1-digit code. So you want to modify it by doing, I'm going to create this thing called S code here. Instead of code, so 1, 2, 3, 4. This is an S code, which means the code, but as a string, is what I'm trying to say here. And I'm just going to append a 0, right, in front of the number. I'm going to concatenate the actual code, but I'm going to typecast it to string. Do you guys see what I'm doing? I'm converting it into a string and putting that 0 in front of it. And for if in the cases where it's greater than 10, then you don't have to do that because it already has 2 digits. So in this case, 1, 2, 3, 4. S code, it should only need to be, typecasting the original code. Got it, guys? That's it. I'm almost done with this one. Now, So the encryption function is done, and now you should only need to write the decrypt function, which is the same thing in reverse. So this should be SS equal SS plus S code, of course. All right, I can probably get rid of these. I'm just going to comment them out. Oops. Okay, and now we should be able to encrypt this whole sentence and get our cipher. So let's see if it works. That doesn't look right. Right? That doesn't look right. Okay. Oh, right. Why is that? Because I hard coded the letters, right? So I need to remember I was hard coding the letters here. So make sure you remove this when I was doing the debugging and enable this part where it's actually grabbing each letter and converting it. Make sense, guys? Yeah. So Control X, Y, clear. Oh, there you go. Your first cipher from scratch. It's a substitution cipher. Pretty insecure, as you can see. Lots of patterns going on, yet not so straightforward to code, right? And, you know, it has its own complexity. And so complexity does not mean secure. Yeah, go ahead. Yeah, of course, yeah. Yep. Any questions, guys? So that's it as far as the lab today. We've completed the encrypt function. You've got it as an output. Now you need to take that and decrypt it and get the sentence back. And that would be your homework assignment for this week. All right. Next week on Tuesday, we will start a new topic. Okay. So we'll start getting even deeper into all the primitives, block ciphers, and principles. All right, guys. So that's have a good Labor Day weekend. No classes on Monday, and then I'll see you guys on Tuesday. That's week 3, right? We're already starting week 3, and it seems like we just started, right? So, all right. Don't forget to submit your homework assignment. Remember, soft deadline tonight, but it'll still stay open until Sunday. All right. Have a good weekend.